Hello, I'm Luke from CQ and we'll be delivering this presentation on structural load types. These are live loads, dead loads, static loads and dynamic loads in which will be expressed in terms of forces that define the load types. This then leads to the effect that the forces have upon a structure such as bending or compression, for example. So what will be covered? Explanation of loads, the effect these loads have in terms of forces, natural loads and why these are considered, and a conclusion in reference to design and construction purposes. Live loads are a force that could possibly be applied to a structure, for example the weight of people or other objects that could move and may not be there all the time. This is also referred to as a probabilistic load, as it is a load that is predicted to be encountered but may not be present all the time. Alongside live loads, there are dead loads, in which consist of the weight of the structure itself, including all the materials and any permanent features. For example, in a housing structure, the dead load would consist of features such as columns, beams, girders, the floor slab, roofing, walls, windows, plumbing, electrical fixtures, plants, equipment, and other miscellaneous attachments that are all permanent. Dead load often changes throughout the design and construction stage as different components are added and needs to be considered for the overall stability. Moving on to the state of the load, it is to be considered as static or dynamic. Static meaning the load is at rest, and dynamic the load, or force rather, is in motion, either moving on the structure or being impacted upon the structure. These loads are important in recognizing whether the material or structure in question is going to be impacted and which would incur a greater force than if it were static. While these loads are important, it is vital for almost all structures to consider natural loads such as wind, snow, water, and seismic activity. These are generally described as a build-up of snow or water, for example, which would exert pressure on a structure. These ratings or safety factors can be found in Australian Standards document AS 1170.2, where they can be implemented into the load calculations of a structure. While these are called natural loads, they can be considered live loads as well. In considering these loads, the effect these loads have upon a subject can be expressed in terms of forces. Commonly considered forces are compression, tension, bending, shear, and torsion as external loads applied to a structure. The concept of stress, strain, and elasticity define the deformation and physical changes in the structure. Stress describes how much force is needed to make the material fail, while strain is how much the material can stretch or be placed under compression. The effect these loads have upon a structure can be explained in terms of compression, tension, bending, shear, and torsion forces. A common force applied to a structure is compression. This is a force that would push the material together, such as an object being placed on top of a structural element, and due to gravity, the opposing ground, the structural element, is in compression. This is more clearly defined in the image provided, describing the difference between tension and compression. Tension, on the other hand, is the opposite reaction, with a pulling force. This is where material or structure in question is being pulled apart by the force as described in the tension diagram. An example of this is tug of war, where the rope is the material in question and the material is being stretched and pulled in opposing directions. A key observation to be made here to this beam is that the force is being applied along the length of the structure and not across the breadth of it. This diagram defines bending as a force across the beam that consists of both compression and tension. As demonstrated in this diagram, the inner arc of the bending material is under compression stresses and the outer of the bending material under the material is in tension stress. Shear force or shear stress is a compression force applied to a material in an opposite direction across the perpendicular plane. A direct practical use of shear force is scissors, in which they can cut thin paper and even metal through the method of perpendicular forces either side of the material in question. In the sense of a beam or structure, this force should be a major consideration as they are the common reason for structure failure. This common force also refers to fasteners such as bolts, nails, screws, welds, and rivets. Torsion or torque, likewise, is a twisting force or motion that would rotate a material apart. Like bending force, the material in question is under both compression and tension forces. This type of force is most commonly encountered in auto mechanics and mechanical systems such as engines and their respective moving parts. As a final force consideration, indirect forces should be considered. These are the forces that could possibly arise from temperature changes in the structure, settlement of foundations, shrinkage, or expansion of materials. These factors should be considered by the designer and determine the significance or likeliness of these forces to occur. If these are a problem, the behavior of these factors and materials should be encountered to ensure the success of the design and structure. In light of this information, it enables the designer to predict and contradict the load being applied to the structure, as it may be desirable to choose specific material types to specific dimensions with certain strength or elasticity depending upon the purpose. More importantly, the loads are combined to find the worst possible scenario and greatest effect from the forces that could be encountered by the structure. This also refers to elements such as a table leg, where in the design phase all 5 types of force should be considered as at some point in time they will undergo these stresses. In conclusion, this suggests that the types of loads and the effects these loads have in terms of forces need to be considered in design and construction phases to assure an optimum result. Thanks for your time.